So in this third video on trigonometry, we'll be looking at how we can use the trig ratios to find missing angles on right angle triangles. So before we go through trying how to find missing angles on right angle triangles using trigonometry, let's have a quick refresh on how to find missing sides of right angle triangles using trig. So if you'd like to pause the video and have a go at these three questions, and then I'll then go through the answers of what you should have. So working through these questions, let's show a bit of working out just in case you don't get the correct answer. So for the first one, what we need to do is label the sides. So we've got H and we've got A. So the rule we need to use is going to be cos. So it's going to be cos 36 equals x over 5. So x is going to equal 5 times cos 36. And if you type that into your calculator, so 5 times cos 36 gives me an answer of 4.0 to 1 decimal place. So x equals 4.0 centimetres to 1 decimal place. So looking at number 2, so again here I've got my opposite, I've got my adjacent, and I've got my theta, so I'm going to be using tan. So I've got tan 70 equals x over 15, so x is going to equal 15 times tan 70, and if I type that into my calculator, so 15 times tan 70, I get an answer of 41.2 centimeters, and that's to 1 decimal place. And then finally for question 3, so again here I've got my hypotenuse, I've got my theta, and I've got my opposite. So here I'm going to use my sine rule. So it's sine 56 equals, and it's going to be 9.9 over x. Now as you can see, x is at the bottom, so when x is at the bottom we need to divide, so it's going to be 9.9 divided by sine 56, and if I just quickly type that into my calculator, divided by sine 56, I get an answer of 11.9 centimeters. Centimeters, yeah. So hopefully you've got the same answers, and again, if you're not too sure you've got the wrong answers, then something that I would strongly recommend is that you watch the previous video and have a go at some of the worksheet questions. So moving on from that, what do we get? So again, a quick refresh on the trig ratios. So again, it's really important you understand and can memorize and recite these trig ratios. And like I said, there are many ways for you to remember this particular these set of formulas. So either SOHCAHTOA is probably the most common one, but there are plenty of mnemonics that you can remember if you just Google them. Some of them are controversial, some of them not so, some you can say out loud, some you definitely can't say out loud. But any way that makes you remember these trig ratios is going to be a bonus for you. Now, moving on from that, the good thing about working out the angle, which is the main theme of this particular tutorial, is that the method is exactly the same. So the first thing you want to do is label the triangle, leaving blank things blank. The second step is you then want to pick the correct ratio and write down the formula. The third step is you substitute the values into the formula, and then the fourth step, and this is the only thing that's going to be different, is we need to solve it for x. Now the only reason why it's going to be different for this is because in these questions we're obviously finding angles, whereas in the previous video we were finding the sides. So from this then, let's have a look at what the difference is. So when finding the angles, to find the size of an angle using trigonometry, we use the inverse functions of trig, and these are represented by sine to the inverse sine, inverse cos, inverse tan. Now, I know some of you might be tempted to call this sine minus 1, cos minus 1, tan minus 1, like many of my students in my class. However, the proper name is inverse sine, inverse cos, and inverse tan. Now these functions are usually found on your calculator as a second function or shift functions above your sine, cos and tan buttons. So as you can see on the calculator, where the inverse sine, where you should be able to spot the inverse sine and inverse tan. So as you can see, although the buttons are quite small, my inverse sine is just above there, my inverse cos is just above there, and inverse tan is just above there. Now to access these buttons, what I need to do is press shift first and then press the cos, tan or sine button. So It might be classed as a second function, it might be a shift, depending on your scientific calculator, but hopefully you'll be able to find it, and then it should come up on the screen as sine minus 1 with a bracket, or cos minus 1 with a bracket, or even tan minus 1 with a bracket opening. So if we have a look at just practicing using these functions, so on your calculator, if you press second function or shift and then enter 3 divided by 8, or use your fraction button, it's entirely up to you, we should get an answer of 22.024312284. Now I'm not too worried about the rounding, but as long as you're getting these numbers, then we are using it correctly. Now for number 2, we need to press second function cos, so you should have a cos minus 1 comes up. Now this time we're entering a decimal number, and again, doesn't make a smidgen of difference. So here we've got cos minus 1, inverse cos of 0.472, which gives us an answer, what should read on your calculator as 61.83580063. And finally, for using the inverse tan, so second function tan minus 1 should come up on your calculator, and then we're going to do 12 divided by 5 equals, and then the correct answer you should have is 67.38013505. Now if you've got those three answers on your calculator, then you have done the correct method and you correctly used your second function or shift function on your calculator. So let's see how these reflect on how we go about working out the missing angles on right angle triangles. So the first thing we want to do, and again going through the steps, is we label the triangle, ignoring any sort of blank sides or any blank information that we've got. So here my theta is x, this side is my hypotenuse, and this side is my opposite. So I've got h equals 14 and h equals 23 and O equals 14. So the next thing I then need to do is use the correct formula. So here I'm going to use sine. So I've got sine equals opposite over hypotenuse. And then the third step, what I then need to do is substitute the numbers into the formula. And that's what I've got. Now at this stage, what we need to do, so to get rid of the trig ratio, use, and it's going to be the inverse function, so sine minus 1, cos minus 1, tan minus 1 with the fraction, or in other words the right hand side. So what we mean by this, so we'll just put this in a bubble. So for step 4 of solving it to find out x, so x is going to equal, now because we're dealing with sine in this question, we need to use the inverse function of sine, and then we do 14 divided by 23. So we're going to take the fraction in its entirety, and if I type that into my calculator, inverse sine 14 divided by 23, I should get an answer of 37.49524976, and rounded up to one decimal place is going to be 37.5 degrees. So moving on to our second example. So again, let's go for a different colour this time. So again, step 1 is we need to label the triangle. So my theta equals x, my hypotenuse is 13, and my adjacent is 9. So the rule I need to use for where it uses a and h. So again, if I'm not too sure, let's just quickly write down SOHCAHTOA. So here I've got a and h, so I'm looking at which trig ratio uses a and h. That's going to be cos. So I've got cos theta equals adjacent over hypotenuse. So then the third step, I just need to substitute the numbers in. So I've got cos x equals 9 over 13. And then step 4 is what I then need to do to get rid of the cos. I need to use the inverse function of cos of 9 over 13. And that all equals x. Now I understand that I've written x on the right hand side, it doesn't really make a difference, but this is what I need to type into my calculator, and if I type that into my calculator correctly, I should end up with an answer of 46.1869 3854, and that to one decimal place is going to be 46.2 degrees. Now moving on to our last example. So here, as you can see, the triangle's slightly disorientated in terms of how it's represented, but it doesn't make a difference because I've just got to go through the steps of labeling this triangle. So here I've got theta, this is going to be my opposite, and this is going to be my adjacent. So if I just write down the information that I know, so theta is x, opposite is 14, the adjacent is 53. So which trig ratios uses O and A? So I've written that wrong. Oh no, I haven't quite right. So SOHCAHTOA, and so it's tan is what I'm going to be using. So I've got tan theta equals opposite over adjacent. Substituting numbers in, I've got tan x equals 14 over 53. So solving for x, I've got x equals the inverse tan of 14 over 53, which I've not written correctly, but now I have. So x is going to equal, so I'm going to do inverse tan of 14 over 53 equals, and it should give you an answer of 14.79676225, which to one decimal place is 14.8 degrees. So hopefully this makes a little bit of sense of terms of and how this slightly differs from working out the missing sides of a triangle, of a right angle triangle I should say, using trigonometry. If you have any further questions then or would like an accompanying worksheet for this particular video, then drop me an email at 162maths@gmail.com.